All right, so good afternoon and welcome. January 2019 says, the diagram below, not drawn to scale, shows an open cylindrical container made with a circular base of uniform thickness throughout. So here I have a glass, and I did send you all to get a glass. So this is my cylindrical container. The length of the container from the top to the outer bottom, from the top to the outer bottom is 120. Are you all seeing my glass?
Yes, miss.
All right. Are you all seeing that this outer length here where my finger is passing, this is 120. Now look in the glass. Is there a thickness in the base? Or in your glass that you have at home, is there a thickness in the base?
Yeah, miss.
Right.
Yes, miss.
So sometimes in these measurement questions, we need to be very practical to understand the question, right? So there's a thickness in the base. So listen to me. This outer length is 120. Look at where I'm going to put my finger here to the bottom. If I take some water from my bottle and I pour it into my glass, no water is touching the base here. So there's a thickness. So really, it is a shorter distance inside the glass. Do you all see that?
Yeah, miss.
Yes, miss.
So we have to take into consideration the bottom of the glass, because this thickness, it is thick glass here at the bottom. I can't put anything, or I can't put water to the very end here because the glass has a thickness. So the water could only start where the thickness stops there. So let me get it straight. If you take your hand, you pass it on the outside surface of the glass. This length is 120. However, there's a thick bottom. So it means that water cannot go down to 120 centimeters because the thickness of the bottom stops or prevents water from filling all the way to 120 centimeters. Now, let's look at the glass here. I have two circles. I have an inside circle, and you all have a glass at home. You have an inside circle, and you have an outside circle. Now, obviously, there's thickness inside the glass, right? Because it is a glass. So the radius inside the glass is going to be smaller than the radius outside. You agree?
Yeah.
Right. So the first thing we're going to do, we are going to draw a cross section. What do I mean by a cross section? If I look straight down in my glass, or I'm showing you on my screen, you see this is what I'm seeing. It is two circles, one inside and one outside. That is what I mean by the cross section. So it is like if you put your glass on your surface and you look straight down, that is your cross section. So we're going to see two circles. We're going to see a big circle and we're going to see a small one. So that's what we're going to draw. So that is the first part. So you're going to draw a big circle and you're going to draw a small one. Now, they told you that the inner radii is 14. So this radius is 14. And the outer one, meaning the bigger circle, is 15. So that is what we want to see. We want to see 15, we want to see 14, we want to see, when we watch the glass, we see in two circles, a small one inside and a big one outside. Let me know when you all are finished. Is anyone still writing?
No, miss. Police.
Show the capacity, and CXC likes to bring these questions. They give you the answer and they want you to prove it. So if you get anything other than that, guess what? You're not going to get any marks. They give you the answer. You show them how they got the answer. The internal capacity. Now we're going back to this glass again, right? Let me use the big glass. We already established that if I pass my hand on the outside of the glass, the length is 120. If I put my hand inside the glass, there's a thick bottom. So it means that water is not filled to 120 centimeters because there is a thick bottom. So the internal capacity is smaller than the outside because the glass has a thick bottom, and each glass has a thick bottom. It does not hold water all the way to the bottom. So this is a cylinder. We need to know what the volume of a cylinder is, and we need to know the formula. So write it in red, write it somewhere and learn it. Volume of a cylinder is pi r squared h. Write it somewhere and learn it. CXC actually likes to bring the cylinder. And quite frankly, they now started to bring the code. So you see that formula, learn it. Put it somewhere, commit that to memory, pi r squared height. Now, we're going back to the question. Remember my thick bottom here. They said something interesting. There is a uniform thickness throughout. So which means right around, there's a uniform thickness of 1 centimeter. Well, how did I come up with that? I didn't make it up. If the inner circle has a radius of 14 and the outer circle has a radius of 15, then the thickness is 1 centimeter. And the question says there's a uniform thickness. So right around in the glass, there's a uniform thickness of 1 centimeter. So when I pour my liquid, it's not going to 120 centimeters, but it is going to 119 because the thick bottom prevents me from filling in the whole glass. So therefore, the internal here would be 120 minus 1, which is 119. We have to take into consideration the thick bottom here. It is, they want the internal capacity, that is what is inside of the glass. So pi is 22/7. So don't make up your own thing. The people say pi is 22/7, so you try and use that. So 22/7 multiplied by the height here is 119. And the radius. Now, they're asking for the capacity of the container. Well, capacity, if we want the inside of the glass or how much volume can fill inside the glass, it is the inside. The capacity is how much water or how much liquid can fill in the glass. So we are concerned with the radius inside the glass, not the outside. The capacity is how much volume my cylindrical container can fill. So this will be multiplied by 14 squared. So work it out.
Yeah, Miss, you get 73,304 centimeters.
73,304 centimeters cube. So this is proven. Just to show them that you know what you're doing. Another thing you could write is QED, which means that that was quite easily done. If you don't write it, that's fine. Determine the volume of material used. So here what? We're going back to the glass. The internal capacity is 73,304. I want to know how much material was used to make this cylindrical container. Remember, the glass is hollow, so there's nothing inside. So if I work out the outside, or I work out the volume of the external cylinder, and I subtract the internal volume, I will get the volume of material used to make the container because it's hollow. So let us find the external volume. The formula again, pi r squared height. Now, this is the outside. So we're using the 120 and we're using the bigger radius, which is 15. So work it out. 22 over 7 multiplied by 15 squared multiplied by 120. All right, who has an answer?
Yes, Miss, 84,857.14 centimeters.
84,000 just now, and equal 22 over 7 by 15 squared. Right, 84,857.14. Is that what you got?
Yes, Miss.
All right, now watch it. If I had to make this solid, I will use 84,857 cm cube of material. If I had to make the inside solid, I will use 73,304. However, this is hollow. So to find the volume of material used, we will take the larger volume, which is the outside minus the inside. So let's work it out. So it is the external volume subtract the internal volume. And it's 3 marks, it's volume. So remember to put your units. And I want the answer to 2 decimal places. All right, who would like to share?
Miss, I got 11,553.14.
Yes, very good. And what is the units?
cm cube.
Centimeter cube, very good. Now, remember, we're not leaving anything to chance and we don't want them to take a mark out for anything. So it is volume, that is 3-dimensional. So volume, the units of volume are centimeter cube. So are we okay so far?
Yes.
Given the density of material used to make the container is 2.2 grams per cm cube, determine the mass. Now, this is the formula. So we need to manipulate this to make mass the subject. So density is equal to mass over volume. I want mass to be my subject. So which means I must multiply both sides by the volume. This is going to cancel and I will get volume alone on one side. So the density multiplied by the mass will give me the volume. So they told us the density is 2.2. We have the volume from the previous part. So 2.2 multiplied by, no, we want determining mass. So we want, just somewhere I make the wrong thing the subject here. So it's mass over volume, mass over volume. So, oh yes. This one. So multiply by, this is supposed to be mass and here is supposed to be volume. So density by volume is equal to mass. The volume is 11,553.14. Work out the mass. All right, who has an answer? Does anybody have an answer? Does anybody have an answer?
Yes, I got 25,417.
417. All right. I'll take that. Or I will take 25,416.91. Anyone you have, I will take that. They didn't specify the level of accuracy, so you can get away with it. Now, this is in grams. We need to get in the habit of underlining key things. The density here is given in grams. However, they want the mass in kg. So you'll get 1 mark here. To get your second mark, you have to convert from grams to kg. So you're dividing 25416.91 divided by 1,000. Because there are 1,000 grams in 1 kg, you will get 24.4 kg or 0.42. Any of those answers we will take. We have to get in the habit of reading the question and underlining what is important. They give us the density in grams, so we could probably circle this. They gave us it in grams and they want now the answer in kg. So that is important. All right, I want you to find for me January 2021. Find January 2021. I know I skipped out some of the questions, but I'll come back to it. I want to do January 2021. You will find it for me. And I want you to go and get a bowl with some water and a glass. We have the glass already. Go and get the bowl with some water and come back. All right. I forgot to tell you that the bowl is supposed to be rectangular. Did you all come back?
I'm trying to find it in my book and I'm looking for it, but I'm seeing it.
You're not finding Jan 2021?
No.
Is anybody finding it in their booklet?
Yes, page 122.
All right. Ronaldinho, check on page 122. You find it? Did you find it?
Yeah, miss.
All right.
Yeah, miss.
So the diagram below shows a rectangular tank. CXC likes to bring these cuboid, they like to bring the cylinder. Now this is my fish bowl, right? So it's rectangular. It is measuring. So you're seeing it have a long side. You're seeing we have a short side. Now I did add something to the water because if it was transparent, you would not be able to see it, all right? So I did add some food coloring. So this is my fish bowl, and I am sure that you all know what a fish bowl looks like. And I'm sure that you have seen a fish bowl. It's rectangular. It has a long side, which is called the length. It has a short side, which is called the width. And the height of the water we represent as h. Notice that my fish bowl is not completely filled. There is space for me to pour water. I only have a small height filled, right? So the fish bowl is partially filled because there is still a volume that is not filled. So we want to work out the volume of water in the tank. Volume is a three-dimensional quantity, which means you have to multiply 3 sides. This is a cuboid. So the volume, length by width by height. This is another one that you want to learn. So we have the length, we have the width, and the height of the water is 15. So go ahead, find the volume of water in the tank.
$30,000.
30,000. Who could confirm that 30,000 is correct?
Yes, miss.
Now we multiply the length by the width by the height. So this is centimeter cube. Volume is 3-dimensional. So the units is centimeter cube. Are we okay so far?
Yeah, miss.
Well, this is where it's getting exciting now. So you see, they're bringing the cylindrical container again. So we need to learn the formula of volume of a cylinder. So here what? I have my fish bowl with 30,000 centimeter cube of water. So I'm going to put that aside. And I'm going to get a new container that I'm going to fetch more water. So this is a cylinder. So we need to work out the volume. The cylindrical container shown in the diagram is used to fetch more water. Notice that my rectangular tank had space for me to add more water. So the container is completely filled with water and has a radius of 20 centimeters, measuring 21 cm in length. If they had given you the diameter, you would have to divide it by 2. However, they gave you the radius. So I am filling this. We're going to pretend, right? Because we don't want to make any mess here. We're going to pretend this is filled. So let me use the short glass. So I fill this. I want to know what is the capacity, what is the volume of water. So volume of a cylinder is pi r squared height. We need to learn this. They gave us the radius. If they gave the diameter, you would divide it by 2. They gave us the height, which is 21. They told you to use pi as 22/7. So let's work it out. 22/7 by 20 by 20 by 21. Work it out.
It's 26,400.
26,400. Who could confirm that?
Yes, miss.
All right. So we have 26,400. Volume again in cm cube. Now we're going back. All this water is poured into this tank. So obviously, the height of the water is going to increase because to the volume that I had before, I have increased it by 26,400. How am I going to find the total capacity or the total volume? I had 30,000. I increased the volume by 26,400. How am I finding the total volume? What do I do?
Add.
So I add 30,000 plus 26,400. How much is that?
56,400 cm cube.
Very good. So we're making it as practical and as meaningful as possible. I started off. This is 30,000. You're seeing how it only have a little bit? I am taking my full glass of water and I am pouring it. So now the volume has increased by 26,400. So in my fish bowl, I have 56,400. Do you all understand that?
Yeah, miss.
Right.
Yeah, miss.
Let us continue. Show that the new depth of water in the rectangular tank is 28.2 centimeters. Now, remember before the height was 15. The height was originally 15. Obviously, when I pour all this water inside here, the height is going to increase. It is no longer going to be 15. So the only thing that changing is the height. The length and the width of my fish bowl remains the same. This is still 50. This is still 40. The only thing in change is when I add all the water, the height increased. So you see the cross section, which is the rectangle, that remained the same. The only thing changed was the height. So for 2 marks, the new volume is equal to 56,400. And volume of the cuboid, length by width by height. This is equal to 56,400. I just mentioned that the length and the width remain constant. That didn't change. The container didn't get smaller or larger. So let me go back. The length, 50 by 40, remain fixed. So 50 by 40 by H is equal to 56,400. So I need to make H the subject. By making H the subject, I need to eliminate. I need to get rid of 50 on 40. So the only way for me to do that is to divide both sides by 50 multiplied by 40. So work it out and see if you get that answer there.
Yes, miss.
All right. So Nicole, you are confirming it is 28.2 centimeters. Yes?
Yes, miss.
Right. The last part of the question. The vertical height. So we're going back. They are telling you the vertical height of my container is 48. We want to know how many cylindrical containers I must pour in order for the container to fill. So we have to work out the capacity or the volume of the fill tank, right? So the volume or the volume of the rectangular tank It is a rectangle. Volume is 3-dimensional. Length by width by height. The length is 50. The width is 40. That stays. The height now is 48. Work that out for me. What is the volume of the tank with the height 58 centimeters? Anybody? 50 by 40 by 48.
96,000.
96,000 centimeter cube. So if my container was empty, the capacity is 96,500. So this is some practical mathematics. First, in the first part of the question, I had 30,000. So you see, at the beginning, I had 30,000. Then I took my filled cylindrical container and I added that. So now I have 56,400. But the capacity of the container is 96,000. So the volume needed to fill is 96,000 minus 56,400, which is 39,600. Work that and see if you get an answer. Can anybody confirm this?
Yeah, miss.
All right, we're going again. Now, you need to fill this and you're using this vessel. The question is, how many glasses are you going to pour to fill the container? Well, in order to know that, you have to know the capacity of the cylinder. And the capacity of the cylinder was 26,400. So one cylinder holds 26,000. One cylinder holds 26,400 centimeter cube. So the number of cylinders needed is 39,600 divided by 26,400. Work it out. So you don't have to guess. You can probably fill one. It may still not reach to the top. We want to know how many cylindrical containers do we pour into the rectangular container so that the volume is filled.
1.5.
1.5. Very good. All right. We will do one question again. It is 6:20. We are taking a break for 10 minutes. When you all return, we will do one question. All right. So we're taking a break for 10 minutes.
Okay.
All right, have you all returned? Are you all back?
Yeah, miss.
Find in your booklet June 2019. Tell me what
Yeah,
page is it? What page is it? June 2019.
Page 52.
All right. Now, I urge you and I encourage you to read the first or the top or the first few lines of the question. It holds so much information, and sometimes students get straight into the question without even reading it. We need to read the question. The diagram shown below shows the cross section of two cylindrical jars. So right away, we have to use the volume of a cylinder somewhere in the question. The volume of a cylinder, pi r squared h. So it means I need the height and I need the radius. The diameters of jar X is 3D. I never tell you anything about the diameter. I told you we need the radius. So right away, if the diameter is 3D, then the radius is 3D on 2. Don't be discouraged and don't be intimidated by the variable d. D can be x, it could be a number, right? It could be y. Do you all understand how I got the radius?
Yeah, miss.
The radius is half of the diameter.
Yeah.
The radius is half of the diameter. Right? So jar Y now has a radius of D. So if the diameter is D, write for me in your book what the radius will be. Don't tell me as yet. If the diameter is D, using the same principle as jar X, write what you think the radius of jar Y will be. You are supposed to have D divided by 2. Do you all have that?
Yes, miss.
Right. So you see, we didn't even reach the question as yet. We didn't even reach part 1. And you see how much information we have? So I encourage you to highlight or to underline the parts of the question that are utmost important. We need to get in the habit of underlining the parts that are important. Determine the volume of water in jar X. Jar X is a cylinder. This is the formula. Let's work it out. Too small. Volume of jar X, the formula is pi r squared height. You can leave pi as it is. They didn't give you what pi is, so they told you to leave pi and d as it is. They never said to change pi to 22/7 or to change pi to 3.142. The question says in terms of pi and d, so leave it alone. So pi remains the same. The radius is 3d on 2. And we squaring that. And the height here is 4. So work it out. And if you don't know what is 3 on 2 squared, use the handy dandy calculator, please. Don't put something that you feel it is, right? We're not leaving anything to chance. If you don't know what is 3 on 2 squared, take it, punch it in the calculator, and you will get the answer. This is equal to pi multiplied by 3d on 2 by 3d on 2 by 4. See what could cancel. All right. 2 could go into 4 2 times. 2 could go into 2 1 time. So pi multiplied by, so we put in pi, and 3 by 3 is 9, and d by d is d squared. So I have 9d squared pi centimeter cube. Did anybody get this?
Yeah, miss.
So let us try not to complicate it, right? 3 over 2 squared is simply 3 over 2 by 3 over 2. 3 by 3, 9, 2 by 2, 4. We can multiply this by 4 over 1 and we will get 9. 9d squared pi. So if you didn't get it, take it down and I will give you a chance to work out the volume of jar Y. Is anybody still writing?
Yeah, miss. Almost finished.
All right, no problem.
Yeah, miss. Okay, go ahead.
If all the water from jar X is poured into jar Y, calculate the height it will reach. So we're going back. Let us assume this is jar X. This container is wide. This container is narrow. I am taking my volume from jar X and I'm pouring it. So you see how the volume is now higher because this container is slim compared to this wide one. So I want to know what is the height of this jar. Watch it. This one was 4. This container has a wide mouth here. This is jar Y. So obviously the height is going to be more than 4. All right, so let's see. Work out for me the volume of water in jar Y. The formula is pi r squared h. The radius here is 9 on 2. So we're following the same thing there. Pi multiplied by d on 2 squared by h. Simplify this for me. D on 2 squared. Simplify that for me and get an answer in terms of d squared. Go ahead and try it. So this is d on 2 multiplied by d on 2. This is d squared on 4. So pi multiplied by d squared on 4h. Did anybody get it?
Yeah, miss.
Now, remember, this is the volume in the cylinder. So this volume is the volume that I had in my Y tank. And if I poured this from into here, I want to find the new height. So therefore, the volume of jar X, which is 9 d squared pi, is the same as the volume of jar Y. This is pi multiplied by d squared on 4 by h. Don't get confused, because both sides have pi, so we can cross that out. Both sides have d squared, so we can cross that out. We want to make h the subject, so multiply each side by 4. 9 by 4 is the same as 4h divided by h. So h is 36. So originally, the height was 4, but because we have a slim container and I pour the contents, the height now of this cylinder is 36. Now, we did 3 questions today. I encourage you to go through the questions and to redo it. The measurement part of the question, it's the more practical aspect. That is why I did it in a more practical sense. Learn the formulas for the different containers, the cylinder, the cuboid, learn all of those. CXC likes to bring those, right? We have 3 questions outstanding in question 6. We will do that tomorrow. In Friday's class, we go to the multiple choice and we continue, right? So I am preparing you to get the gist of all the questions. As I want to emphasize, we may not be able to get every single mark in each question, but there must be some parts of the question where we will get correct. So it is a work in progress. We are not there yet. The attendance is exceptional this evening. I want to thank you for joining me, and I want to end here because I know that some of you all are exhausted. So I will see you all at 5:30 tomorrow.